Fine now, don't know about the future. What's wrong with the future? What are we doing today? We're continuing with the organic. Oh, mocks in 2 weeks. What's coming in chemistry? What is coming in chemistry? The whole syllabus. Okay. Hello, Abdullah. How are you? Okay. Can I do a few things before we begin? Okay. Any questions from the last class so far? That's a bit strange. Okay. Thank you. Okay, let's start. So you guys were introduced to organic molecules for the first time yesterday. Well, not really the first time, second time kind of. But yeah, importantly yesterday, and you guys were doing a lot. Okay. Now one thing I want to say is the part that was really important is, or not important, how you want to see everything is that organic molecules do act like Legos, or carbon especially acts as a Lego piece. Okay, and you've seen it, especially when we were comparing a bit of hydrocarbons with allotropes of carbons. We see that carbon does end up behaving very similar to a Lego piece. And you take one carbon and you can just have, like a whole chain, or like an entire structure, like a diamond, or you could have sheets of carbon, like when we see with graphene, and many things. Carbon also ends up conducting electricity when it's graphite or graphene. In other cases, it does not. So carbon's like versatile would be an understatement. Take it. So hydrocarbons are just get very complicated as well. They get very complicated. So what you'll end up seeing, and you've seen it, is a hydrocarbon like this. Keeps on going, and that's one example. And let me draw the hydrogens real quick on it. Okay, and this is a different 3, 4, 5, 6, 7, 8. And we have hydrogens on it. Okay. So not only, like, they can get really long. Right? Here's one example. Now how long? They could be hundreds, if not thousands, of carbons repeating. So this chain of sorts could be, of carbons could be hundreds, thousands of carbons long. And those molecules are important. You see them or are with them every day of your life. But we'll keep our things simple. Hi Arisha, assalamu alaikum. Okay. One such simple thing is we'll deal primarily with carbons that are in one line, or as we like to call them, are in a chain. Which means that each carbon is connected to another carbon, and so on and so forth. Keeps on going, right? An alternative to this would be a branched hydrocarbon. So you have a straight chained, hydrocarbon and a branched hydrocarbon. And a good example for this is This is butane. And I'm just gonna cheat because I want to save some time. I'll copy this here and make the other hydrocarbon. I have enough room for it. Let's make this here and bring this here and H. A little crowded. Let's make this picture. Okay, that looks weird. So the one on the right is branched. The one on the left is a straight chained one. Does this make sense? So how would you identify it? There are multiple ways of it, but you look at it. Oh, that's a horrible color. You look at it and you go, oh, that's a straight chain. And you go over here. This technically is not a straight chain. Okay. With me so far? Why are hydrogens in the end not connected? Which hydrogens? These hydrogens? Hi Asma, how are you? Which hydrogens do you mean, Saad? Or did I fix it? The ones above them? They're not connected? What do you mean? I guess I was drawing too fast. I mean, they are connected. What do you mean? The ones they don't have a stick? Which hydrogens? These ones? Yeah, that's fair. They are connected. What do you mean? Like more than one stick? Why are these not connected आपस में? Oh, hydrogen can make only one bond, right? And this one is bonded with carbon. This one has been bonded with carbon. So this is just poor drawing on my part. Let me make them shorter, the other two, so there's more room. Right? It's hard to draw all of them. Okay. And the other thing is, you have to also appreciate that, let's go there in a bit. But does this make sense? I'll try answering your question in a bit. Does this make sense that this is a straight chain and this is not really in a straight chain? You guys with me so far? Hello, Farwa. How are you guys doing? Okay. Okay, I'll move on. Okay. Now, let's actually come back here. Can you guys tell me if this is a straight chained hydrocarbon or not? Okay, someone says it's not straight chained. Saad thinks it's not straight chained. Okay, let me show you guys something. On left, we have the same structure which I drew earlier. 4 carbons, this is the exact same structure. And on the right, I have the molecule. Okay. This is how the molecule looks in space. Like in real life, if I had to see it. Notice how the Glowing orbs in the middle would be carbon, and the black attached to it are the hydrogens. Okay? So if I were to trace the carbons, look what they're doing. They're making this zigzag sort of pattern. Do you guys notice that? Okay, what's really happening is each carbon, like if I also take a look, if we take also a better look at just one carbon, notice what that looks like. Okay, this is what it looks like. This is one carbon bonded to 4 hydrogens. How would I end up drawing this structure? This is how I would draw it if I were to show all the bonds. My question is, when I draw it here, what is this diagram trying to highlight? And what things are being compromised, or what things are being not shown properly when I draw this diagram? We're continuing organic. Okay, what I'm focusing on is the bonds, how each carbon is arranged with hydrogens around it. That's what I'm focusing on. And to make it neat, because this is not neat on the left hand side. This looks pretty, but for me to draw it, it would look really weird and really hard to process. Especially because this is a 3-dimensional picture and I'm trying to draw a flat picture. So I do a compromise. I try to, yeah. So this is what Saad's saying. It's showing the bonds, but it's not showing the correct bond angles. Okay. Do you guys agree? Spam, yeah. Like I'm getting tired of the spam yes thing. Maybe we can find another way. Do you guys agree? When I draw the diagram over here, I'm not representing how the shape is actually arranged. Yes, yes. Okay, people are getting it. Okay. Over here, I draw it at a 90 degree because it just looks neat that way. If I have something more complicated like this, I draw it in, at 90 degrees to each other. They're all 90 degrees because it just looks neat. And because each carbon makes 4 bonds, it's just well placed. But in reality, that's not how the structure is. You see, it's all zigzag. If I had a longer chain, it would literally just zigzag all the way until the structure ends. Okay. And this happens because that's how carbon makes its bonds. They're at angles. They're not right next to each other. They're not at 90-degree angles. The structure, this you would have to remember, not really this. But this will be more logical and you don't have to remember it eventually. Okay. But does my argument make sense? This is very similar to how you end up seeing water. Let me try drawing a water molecule. Okay, this is how you'll end up seeing a water molecule. Kind of like that. Okay. This is how you'll see it. Trying to color it. And let's get white. Okay. But when you draw it, sometimes you draw it like this when you're trying to show the bonds. But most people are okay with drawing it like this. And that's how you see it a lot of time. Okay. Now, is this representing the real shape of the water molecule? No. Do we care about the actual shape of the water molecule? Not really, because we're focusing on the bonds. So we just try to make it look as neat as possible when we're trying to draw it. Some people like to draw it like this because it's a simple thing to draw. It still looks neat. But when you go to more complicated molecules, you end up drawing it in a straight line rather than this zigzag form. Does this make sense? Spamming yes if we agree. Yes, people get it. Okay. So coming back to this question, is this a straight chained molecule? What do you guys think? Notice how what I mean by straight chain. This is actually zigzagged. By straight chain, I mean they're right next to each other and there's no branching going on. It's not connected like that, right? There's none of this happening. Yes, it is. I've only drawn the same molecule. Let me bring the molecule over here. I can bring it over here. Oh. How do I? Let me bring the same molecule over here. And make it smaller. Okay. I could draw this molecule like this if I wanted to. I could draw it like this if I wanted to, but I could not draw it like this if I wanted to. Why? Because these two represent this molecule because the bonding arrangement is correct. Over here you see this carbon is not bonded to 3 different carbons in the center. They're all right next to each other, right? So over here and over here, they're right next to each other. The very easy way to do this is you take a pen and you trace on top of it. If they're all connecting without you having the need to raise your pen or double back, it's a straight chain. Simple as that. So you guys agree it's a straight chain right now? Yes? NoFix also agrees? Right? So even though I can draw it differently, the molecule, what I'm drawing is just trying to represent the bonds. It does not represent its shape. The shape will remain how it is, how it's meant to be. I can't change its shape. But over here, how I'm drawing it, is up to me. But which would you end up drawing, this or this? Which would you draw? You'll just draw the simpler one. Even though this is not incorrect, there's a way about things, right? You would prefer this over the second drawing because the second drawing is more confusing. And that makes sense? This molecule is considered a branched one. So our limitation will be, when we're talking about hydrocarbons or organic molecules, will primarily be for straight chained ones. So if you start thinking about branched ones, we'll see them a lot, but we won't care for them too much, aside from a few things. Okay. Is that clear? Arsha saying first one? These are called isomers, yes, but we'll talk about isomers in slightly more detail. I just want you to understand the shapes. All clear? We're gonna primarily deal. Abdul Ghani, you're curious, you're asking. This is methyl propane, not butane, but we'll not really get to that, and it's not really part of O levels. But let's move on. Okay. So you guys talked about functional groups. I saw the video. You guys were talking about functional groups. Okay. Functional groups are little things on a hydrocarbon that will define its chemical property. And that's an interesting statement. Okay. Now there are 4 major types of organic molecules which we'll study. Okay. And I want to pick a good color. So we have alkanes. Okay. We'll have alkenes. We'll have alcohols. And we'll have carboxylic acids. 4 main types. And you've seen this before, right? You were doing this yesterday. And let me show you what an alkane is. An alkane does not really have any functional group, really. Okay, alkane does not really have one. So if you were to see a hydrocarbon, what would it look like? It'll just be a straight chain with nothing special attached to it. You see, it's just carbons, it's just hydrogens. Nothing special on it. So, Arisha is asking, why is that so? What exactly are you asking, Arisha? Can you rephrase your question again? Methyl groups and ethyl groups won't be in your syllabus in O levels. You'll see them, but you don't have to worry about them too much. I'm answering Abdul Ghani, who's asking a question on YouTube, if you guys can read. Why doesn't it have a functional group? Well, that's kind of like a... So alkanes is our most basic of hydrocarbons or organic molecules. We just deal with them as pure. They have their own importance, right? It doesn't have one. We just call carbons and hydrogens with nothing else on them and not even any, just simple 4 bonded carbons, alkanes. Okay. We just call them alkanes. It's not like, why doesn't we name them as alkane? What exactly is a functional group? Let me just write it down and we can talk about this question again. Okay. Let me do that. I think once you see something, then you'll realize, oh, the absence of that thing. Okay. So here's a functional group, which is a carbon-carbon double bond. Okay. This is here for alkenes. So for a hydrocarbon, this is how you would see it. Okay. Having a carbon-carbon double bonded is a functional group for an alkene, and that's how you identify alkenes. If there's a carbon-carbon double bond, it's an alkene. Notice how there are less hydrogens compared to the alkane over here with the carbons, right? Okay. Let me also make some more room. Here is another molecule. Okay. And what's different about this, how this is different from everyone else, is that it has OH instead of a hydrogen. So I write OH, but what it actually is an oxygen, then it's bonded to hydrogen. Like that. So alkanes do not have any functional groups, whereas alkenes have this carbon-carbon double bond. Alcohols have this carbon with an OH on it. Actually, I shouldn't highlight the carbon, just the OH. Okay. With me so far? Do you guys see how alkenes, and alcohols are different? I'll tell you, Arisha, I'll answer your question in a bit. What exactly is a functional group? Okay. The last one, I'll draw the same alcohol, very similar. But on one carbon, there's a carbon with an oxygen bonded to it. And there's an OH in front of it again. You mean alkenes, these? Massam, are you asking what are alkenes? Alkynes, they have a carbon triple bond. that's not really in our syllabus, so let's not worry about it. We have enough things to worry about right now. I'm joking. But, ठीक do you guys understand this part? Now, what exactly is a functional group? Now, an alkane or a simple hydrocarbon. A hydrocarbon is a molecule with carbons and a hydrogen. Can you imagine all sets of carbon molecules from starting with one carbon all the way up to hundreds or even thousands? Carboxylic acids will always have this double bonded. Yes, like that. Okay. Now alkanes are not impressive at all. They don't do anything. They have very few reactions. They're more or less inert, right? And we'll get to that if someone has a question, but no, alkanes do these reactions. I'll get to that. But alkanes otherwise, aside from one or two reactions, are completely unimpressive. They don't do anything. ठीक है? But as soon as there's a functional group on an alkane, it does something interesting. And as soon as there's a functional group, let's say there's an OH attached to the same molecule, let me turn this into the same molecule as the rest of them. As the same molecule, this OH is more reactive than the rest of the molecule, because I said this chain is unreactive, right? This molecule is unreactive. But with this OH, this entire molecule becomes reactive. And what reactions can it do? Whatever the OH wants it to do. Whatever reactions the OH wants to do. ठीक है? So this dictates the properties of alcohols. This will dictate its molecule की सारी properties. All of its properties will be dictated. Chemical properties mostly will be dictated by this. Similarly, all of the chemical properties will be dictated by this double bonded alkene, because this makes it more reactive than this guy over here. And similarly for carboxylic acids. This will make it more reactive and react differently than this guy over here. And आपस में all of them will react differently as well. ठीक है? Do you guys understand this part? Spam yes, or I feel there might be slight confusion this time around. Miral says yes. Masam says, Arisha says yes. ठीक है? You guys understand this? Now, Arisha, did I answer your question earlier? What exactly is a functional group? Okay, Arisha, why don't you answer your question again? And I'll try answering it. What is a functional group? ठीक है. A functional group is a part of a molecule that's more reactive, right? Let's compare these two examples. Let me make an alkane or just a carbon. This one over here. So this molecule over here does not have a functional group, right? It's not going to do anything. As long as there are carbons and hydrogens like this in a neat pattern, with each carbon, having 4 bonds, one with another carbon and the rest, it's considered, an alkane. ठीक है? Now the same molecule, if I replace one hydrogen, let's say, now this molecule right now on top, or both of these molecules, do not do anything chemically. Chemically, they can burn, right? Maybe one more reaction, but they'll do absolutely nothing. They're very inert. Think about this. Okay, let's not go there right now. But they're completely unreactive. But as soon as I have a different molecule with an OH present, between the two, this molecule will react with a wider variety of chemicals because the OH is more reactive than any carbon or hydrogen. Okay? And if they're more reactive, they'll react. And if they're reacting, technically this molecule is reacting as well. So if this OH is, present, it adds functionality to the molecule. So we call it a functional group. They're a group of atoms, molecules, or even a carbon-carbon double bond that provides function to a molecule, and OH is one of them. And here are the 3 out of the 4 which we kind of focus on. Miral has a question. Would the whole alkene be in the functional group, or just the carbon-carbon double bond? Yes. So the carbon-carbon double bond for the alkene will be the functional group, not the whole one. So let me also draw a longer alkene. Or actually, let me turn this into an alkene over here. Okay. To turn this into an alkene, I could put the double bond here, 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 or here, anywhere. Anything is fine. If you have seen a pattern from me, I'll normally put it at the end because it looks nicer that way to me. So I'll put it at the end. To put a double bond at the end, I have to remove 2 hydrogens and put a double bond. And right now this is an alkene because this part will make the molecule react more than anything. There are certain chemicals that will react with this part of the molecule. In essence, they're reacting with this entire molecule. Does this make sense? Meral? Arisha? Are you guys following? Okay? You're getting it? Okay. Arisha, a bit more clear? Okay, G, all right. Okay, great. Okay, back here. So what I wanted to kind of focus on was there are quite a few things we're trying to deal with, trying to absorb, right? So one is we want to learn how to organize them. So let's focus on alkanes, shall we? Let's focus on alkanes. Here are alkanes. Okay. And the alkene we ended up drawing had 2 carbons. Okay. Okay. This is an alkane, and you guys can see it's an alkane because it has no active functional group. Okay. Now before I say anything more, when I say carbon dioxide, what comes to your mind? If I say carbon dioxide, what comes to your mind? This is a name of a gas, right? But the name itself is not just any name, like my name is Abul, right? It's not defining anything about me, it's just what I'm called. But carbon dioxide, the name itself is telling you exactly what it is. Okay? It's telling you it has a carbon, it's telling you it has oxygen, and this is telling you there are 2 oxygens. So with a bit of understanding of covalent bonds, you can say, oh, it has to be CO2. Carbon bonded to 2 oxygen atoms. Okay. And you're familiar with this. You have magnesium oxide, you have, dinitrogen monoxide, you have dihydrogen monoxide, if you remember that molecule. Do you guys know what dihydrogen monoxide is? Dihydrogen monoxide. Do you guys recall dihydrogen monoxide? Yeah, pani, right? It's H2O. So you have a naming convention for most molecules. With organic molecules, they're just too many. So it's so you need a better naming convention for it. Do you guys understand that we need a better naming convention for this? Do you guys appreciate that? Because you could have an alkane which could have 2 carbons or 4 carbons or 8 carbons, and technically they're different molecules or different, you know. So we need a very structured, a very methodological way of figuring out what or referring to a particular organic molecule. So here's what this molecule is called. It's called ethane. Right? This is called ethane. And this tells you exactly all about it. Right? Now the eth over here is trying to tell you, you guys don't know this, this is something new. I can't say it today. I'll practice. I'll have to read it. Methodical, methodological. I think methodical. That's the word. Thank you. What eth is trying to say it has 2 carbons. What the ane is trying to say is that it's an alkane. What's what, Arisha? Methodical, applying method, right? Method, do you understand method? So we have to be very sequence wise. How does it say 2 carbons? This is a new word which we'll learn. So eth means 2, and we'll get to that. Okay? So do you guys understand? Organic compound, this is how it's named. So if you have 1 carbon, you could have number of carbons then you have its naming, the prefix you use for it. ठीक है? Or let's make a straighter line. Thank you. You could have 1 carbon, you could have 2 carbon, you could have 3 carbon, you know, and you could have 4 carbon, and so on and so forth. ठीक है? And what you try to highlight is when you have 1 carbon, the name is meth. If you have 2 carbon, you saw this right now, it's eth. I'll put a dash in front of it. Meth. Okay, yeah, someone has seen Breaking Bad and knows. So meth is short for methamphetamines, and the meth is trying to highlight that somewhere in the methamphetamine molecule has a meth or a 1 carbon related structure attached. So that's what meth is. ठीक है? I've never seen meth, so, but I'm positive it's there. For 3 carbons, it's prop. And for 4 carbons, it's going to be bute. Looks like but you say bute. Let me bring this a bit niche. ठीक है? Does this make sense? Are you guys with me? I want you guys to also note this down. Can you guys also write this down? This will be very helpful. ठीक है. We will go there. No, Saad, we will go there. I just want to, I have only room for 4. I also wanted to draw them. So let me just leave some room between them. Now our goal right now is to draw these. Now I'll encourage people on YouTube and in class with us on Zoom to draw it with me. Okay. So let's say if I'm talking about where I'm talking about alkanes, right? So the carbon or the first alkane will be methane. The second one will be ethane or ethane. Third one will be propane. And the fourth one will be butane. Okay, does this make sense? So for alkanes, the first one will be methane because it only has one carbon. The first alkane in the series is just methane. The second one will be ethane, propane, butane. The anes are telling you they're all alkanes. The meth, eth, prop, and but are telling you the number of carbons. Okay. I'm assuming you're busy writing, so I hope you're getting it. So this is what methane looks like. It has one carbon, nothing else on it. So I just filled it out with hydrogens. How many hydrogens? A carbon can make 4 bonds, so I placed 4 hydrogens on it. This is what it looks like. I'm going to make this smaller because I'll need some room. I hope it's not too small. You guys understand how this is methane? Spam yes or spam the Arisha wala emoticon if you guys get it. Miral gets it? Oh, no one wants to do that emoticon? Okay, Arisha got it. Okay, thank you. Okay. Let's try drawing ethane. So ethane has 2 carbons. I'll first draw 2 carbons bonded next to each other. Again, we're focusing on straight lines because the syllabus doesn't get too complicated. Then once I'm done, I want to draw hydrogens around it. So the carbon on the right has 3 hydrogens because it can make up to 3 bonds, and the carbon on the left can have 3 as well. And I'll put the hydrogens on it like that. What I'll do is, I think I'll take propane and butane to the next page. Okay? I'm going to encourage you guys to draw propane and butane. Before I draw it, try drawing it. Practice it out. What could propane look like? You've seen it enough. I'm telling you the number of carbons. What do you think? What do you guys think? Three carbons and eight hydrogens. Exactly. ठीक है. Three carbons, and I'll now surround this with. I want to change my color here. Why won't you let me change my color? Hydrogens. And yes, exactly. Then we have butane. 1, 2, 3, 4. And then I'll fill it with hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Then we have a hydrogen, a second. That's butane. ठीक है? Did you guys get it? Right? Okay. Let's go back here. Let me erase this. This is unnecessary. And I can also make some room. So these are known as display formulas. They're displaying how the bonds are. But I want to know their molecular formula, which tells me the count of atoms. Can we do that? The first one is going to be CH4. All right? Then we have exactly C2H6, where I'm just counting the number of carbons, adding them together, right? Then hydrogens, adding them together. C3H8, Saad already beat me to it, and C4H10. Yes? Okay, let me move on. So if I say, hey, there's a gas leak and propane is leaking, and because you're an academic, you don't run to try to fix the gas, so you try to figure out what exactly is propane and try to imagine its structure. What's the thought process behind it? Well, you'll try to say, well, propane is trying to tell me two things. The prop part and the ane part are trying to tell me two things. This is trying to tell you that it's a straight chained hydrocarbon with nothing else attached to it, right? Like there's nothing else attached to it. The prop is just telling you nothing else, aside from hydrogen, there's nothing else, right? And the prop is telling you that, hey, it's 3 carbons. So, the gas leak is this particular gas. CH3, C3H8. Right? Straightforward? Straightforward? Yes? Okay. Now I was easy. Okay. One thing I want you to do is I want you, everyone, to focus. Remember meth, eth, prop, and but. Know, because they're all new words. Know that they mean 1, 2, 3, and 4. Know them, right? It's organic is so much fun. Oh my god, it's like we'll have a lot of fun drawing and understanding and visualizing. It's very creative. Creative is the wrong word. It's just so Lego-y. I don't know. You're not actually playing with Lego, but you're thinking about Lego by like putting pieces together and like these things, and it gets very fascinating. It's pretty cool. Okay. So here's something I want you guys to focus on. So we did the first 4. Can I talk about a little more? Can I talk about them? We have to end the class soon as well. Sir Bilal will have his other class right after this. Okay. Let's do this. Let's try copying this. Okay. Do you guys understand this table? Do you guys understand this table? What is it trying to tell you? It's trying to tell you the naming convention for the first 10 carbons. Even I think 10 is a bit excessive. If you know till 8, it's more than great. It's perfect, right? If you don't know 9 and 10, that's fine. But if you know it, you won't be too scared when it shows up anywhere, right? But this is straightforward. And by scared, I mean like some random ugly word shows up, even though it has nothing to do with anything. It shows up in your test paper. You're like, oh my God, what is this? So if you know what 9 is and 10 is, it makes sense. But otherwise, here's also a great hint. We did meth, eth, prop, and but. But after but, they're all shapes. The names are inspired by shapes, right? Pentagon, hexagon, heptagon, octagon, I guess nonagon, and decagon or decagon, right? What language is this? I don't know. Greek. But they're all shapes. You know most of these words already. So you'll have more trouble here. Remember what these 4 are. Meth, eth, prop, but. Meth, eth, prop, but. Meth, eth, prop, but. Meth, eth, prop, but. ठीक है. Meth, eth 1 and 2. Prop, but 3 and 4. Language of polygons. The language of shapes. Does this make sense? We'll continue from this tomorrow, or Sir Bilal might continue from this tomorrow. But this is, the earlier you guys wrap your head around this, it'll be so much less scary. Or not scary, you'll be quicker at other things. Yes, Saad? The end for today. Thank you for joining. I should improve my handwriting. Saad, you're absolutely right. Structure सिर्फ butane तक बनाने होते हैं. That's exactly in the syllabus. But you can also appreciate a little more. अगर आपको आ जाएगा, जैसे they won't say butane, they'll say octane is reacting. And if you know a little bit more about it, you know, it won't scare you when this octane shows up. Or if there's a hydrocarbon with, you know, a little more. You're not tested after butane. That's a promise by CIEs. So take it for what you will, right? But to know and be able to draw, like, think about it this way. If you can draw octane, right? It has 8 carbons. If you can draw that without any difficulty, you can draw everything else without difficulty, anything smaller than that. If that makes sense to you, we'll do octane until decane. Okay. All right, I hope you guys enjoyed it. Take care. Bye-bye, guys. I'll see you tomorrow, or you'll see Sir Bilal tomorrow. Maybe we'll both join. Let's have a class like that. Khuda Hafiz, guys. Bye-bye. Thank you, YouTube. You're a great crowd. All two of the 3 people watching. Okay, bye-bye, guys. Take care. I hope you learned something. We'll continue this again tomorrow. Bye-bye. Allah Hafiz.